I would like to share with you today some of the flaws that I have seen myself with JavaScript and how it can be exploited and how it can be used by attackers. So what I would like to present today is several aspects of JavaScript and HTML5 new formats and how they can be exploited and how they bring a security threat to your applications. One of them is actually a sandbox, which is by itself a security feature, but it can be easily broken, that I will show you how. The other one is pretty much known XSS, which can be exacerbated by HTML5 canvas feature. And I also would like to share with you some of the problems that client-side business logic can bring in your application, as well as some of the geolocation problems that also come together with HTML5. So let's get to looking into it. Why is it all even important? The JavaScript items and the JavaScript issues has been with us for a very long time. But what happened is that HTML5 actually brought it to action in a very significant matter. Because currently we see more and more usage of HTML5 since it brings such an easiness and efficiency to the web developers. But the way it brings easiness and efficiency to the web developers, the same way it also brings easiness and efficiency to attackers. And that's using some of the new features and new formats that come together with HTML5. There are a lot of them. I would like to focus today only on some of them, like web storage, which is a really, really convenient concept that brings to client side a lot of ability to store and to and to react in a very fast way for the client by the application. WebSocket, which is an easy communication format. Sandbox attribute that I have already mentioned. Canvas, which is an option for drawing, for graphics usage, and geolocation. Those are the 5 components that I would like to focus today and to show how the security flows come along with the efficiency of those HTML5 attributes. So let's start with Sandbox. Sandbox is a basically security feature, which I would like first to go to basics and to talk about same origin policy. Probably a lot of you know what same origin policy is, but just to make an alignment, same origin policy is an ability to present which is taking control over the iframe while the CNN.com is trying to change its background to green. Will we succeed? Here it will fail, that's right. It will fail because it's not same origin. So that's a fine concept, proved itself pretty well. But what actually happening for a few years now, it's a trend of markets. Markets like Salesforce.com or Microsoft 365 that are actually offering open source developers or any developers to upload extensions or plugins and then offering those plugins to the users. Some of the markets apply security and some security and some not even at all. So what happens to the end user in that case? End user is using actually an extension, a plugin produced by a third party, which can be malicious, but from the user point of view, it's the same origin. And again, also from the site point of view, it's the same origin too. So same origin policy is not working here in that case. So for that, and partially for that and for a few other reasons, HTML5 brought up sandbox concept. Sandbox concept is basically a hardening of the basic same origin policy. From one side, it's hardening from security point of view. On the other side, it's providing a final granularity of taking control over what's allowed and what's not. So let's take a look at the syntax of the sandbox. What sandbox is offering us is to take same origin policy as a default and allow same origin policy just for presenting the content, but leaving submitting forms, running scripts, or allowing top navigation as a separate, leaving it aside and requiring to allow it specifically. So if we have same origin policy allowed, but script is not allowed, then such an action will fail. That restricts those third parties in much more efficient way. So let's also here try to do a small exercise. Let's go back to the same origin policy. We have seen that we have no sandbox. If we have no sandbox, but we do have same origin policy, and we are trying to run the script, which will pop up an alert of number 1, just for example, it will succeed, right? We have just stated that. That works. That's same origin policy. But now we are moving to a more complex example. We have sandbox iframe with same origin policy, and we are again trying to run a script with an alert. Let's see, what do you think? Will it or will it not succeed? Have any votes for successful running of the script? No one, really? And the thing is that it actually will fail. Why will it fail? It's the same origin policy like we have just looked at it the slide before. The difference here is that sandbox. In sandbox, same origin policy is not enough to run the script like it was in the past. Now, with sandbox, you have to specifically permit running the script. If you didn't do that, you can see a specific error stating that you didn't permit running the script, therefore, you can't do that. You are getting an error. So now we are going back. Now we have taken the iframe. We have added sandbox, same origin policy, and allow scripts. Will it now succeed to run the script? That's right. It will, because we have specifically allowed it. So if we go to the next step and we see what's happened with top navigation, we have sandbox iframe. We have same origin policy. We have allowing scripts. Will the top navigation succeed now to take our iframe to hacker.com, or will it fail? What do you say? Fail? It will fail. That's right. It will fail because in sandbox world, you can see that in the top corner there, you have to specifically allow not just the script, but in order for top navigation to succeed, you have to allow top navigation separately. So here we are getting an error of a top navigation. So now we will see a bit more complex script that takes an iframe which allow scripts and same origin policy. And what it is trying to do, it takes find myself, it goes back to the front page. And what does it do to the front page? Because it allows script, it runs a script of add permission. It goes to the front page, it adds permission of top navigation, and voila, we now also have top navigation at our iframe. So what is the next step for that iframe? Navigate to hacker.com. And that's actually breaks the whole concept of the sandbox, because sandbox has specifically stated that you need to allow top navigation. But now we actually have just seen that you don't need to allow top navigation. It's enough to allow scripts, and you are vulnerable to attack of top navigation, which breaks the whole concept of sandbox. What does it mean for developer in JavaScript? What does it mean for someone who is looking at sandbox and actually counting on sandbox, that once you have a script allowed, you are open for attacks? So in case you want to prevent that situation from happening, you have to be specifically not allowing scripts. That's one example of JavaScript flaw, which is brought up by HTML5. Additional one, and a nice example that I would like to show you, is HTML5. It's a sort of cross-script attack, which is exacerbated by Canvas concept of HTML5. Canvas is an element which is actually there just for graphics, but it comes out to be a very powerful element, and it allows us to take a simple XSS and take a lot of information from a non-XSS pages of the same site. For that, I would like to take a simple bookstore project. Bookstore project, a lot of you probably familiar with it. On the login page, bookstore project is vulnerable to cross-site scripting. So what I do, I take and I inject an iframe of itself to the front page. And here, specifically on this picture, you can also see a border that will differentiate our iframe from the front page. That's here only for the example. But I would like to go with you and see how it actually works in real life. So here we don't have the border, but nevertheless we have two pages here online. We have a front page, and we have an iframe which is running itself, running login script, login page. So let's log in. And before we do so, let's take few links for future use. So we have logged in here. We are inside our application, and we are about to do what we came here to do, some registration maybe, whatever additional actions you might do inside. And while doing that, what actually happening is that a background front page, which was accessed from the beginning, is taking pictures of everything that we have done during our activity. So all what we have done now in this site, which is just a bookstore application, we have bought books, probably paid a lot of money, used our credit card number, all this information will be taken picture, and as you can see here, you can also see the password to this site and send to the malicious site. So how did we do that? How did we succeed? And for that, I would like to go back to the presentation. What's going on is that a background picture, a background page is running a script which is besides being, which was accessed, and besides running the page itself and the iframe, it also runs a script, simple script of HTML to Canvas. HTML to Canvas script is using Canvas element to take screenshots of your activity. It takes screenshots, and I just downloaded this script from, it's an open source, it can be found very easily, but I have modified it a bit, you can see here, to reveal password. So I will not only have a picture of everything inside, I will also have a picture of a password that user just used. So what happens? A single XSS just contaminated the rest of the site. It took everything, every content, including password, And in my case, it just kept it for myself. But in an attacker case, it will send it to the proper usage of an attacker. This way, one XSS is exacerbated significantly by a very, very simple graphical concept. It's nothing, not a breaking new. XSS have been here for 10 years and more. But what's new is the easiness. So you can see here how the easiness and efficiency that HTML5 developers gain while developing, the same way attackers gain the same easiness and efficiency while attacking. And I have additional example of doing the same also by using a very simple script available for or as an open source for download. And this example uses WebSocket. WebSocket is a protocol for client-server communication, but what HTML5 brings is an easy usage of this protocol as part of client-side scripts. So what actually can this thing do when client opens, for example, in the same format XSS page, you have an iframe which is running something that you are expecting to see, and on the background there is a script which is running and mapping your internal network. And how can it be done? Let's go here and see JSRecon. JSRecon, it's an online tool that you can open anytime, any day. What does it do? It runs a WebSocket scan, which goes, in our case, I have just opened my IP here of this network. It's not really legal, but I hope OWASP guys will pardon me for that. And I have mapped and scanned few of the IPs of this internal network. They all are down. There is no open port 80 for any of them. But if it could be, what the script could have done, it could start communicating with it. And this way, very efficiently, actually skipping the firewall of this network, because it was totally legit connection which mapped the network and then started communicating through the client to the web services. The mapping of internal network, it's not a totally new concept. There were already scripts existing and ways existing to do that. But what's new here, and what's actually I wanted to point out, is incredible efficiency and easiness of getting to such an information while using such accessible tools in JavaScript and HTML5. So that's another example of WebSocket. The main concept that JavaScripts bring with it is the client-side business logic. JavaScript and HTML5 is built for that. It's built to allow to put a lot of pressure that, and to move it from the server side to client side in order to make the application moving fast, reacting fast, and very agile, if I can say so. But what it's tempting to do for developers is not only to put UI logic on the server side, on the client side, but rather to put business logic on client side. And that is true from what I have seen to a lot of application, a lot of enterprise application. Like again, example of bookstore can be very similar. While doing the shopping carts, a lot of shopping carts and shopping sites are managed on client side just to provide agility. So I have chosen here today a game which is harmless really, and the mess I'm about to do to this game is not really doing a lot of bad things, but that's just an example of what can be done on the client side. So let's take a look at Pac-Man. And Pac-Man brings us back to the 11 age that you have just mentioned. Probably a lot of you don't even know what Pac-Man is. It's the game that was popular 20 years ago, probably one of the first games, and I really loved it. So I have chosen its JavaScript example today to show you how can you make the changes. So what we have here is a basic JavaScript game with Pac-Man who is going eating diamonds and can be attacked by ghosts. Now, the ghosts, we can play the game. I hope it will run. The ghosts are chasing the Pac-Man. There's no responsiveness here. Right, here we go. We're chasing the Pac-Man, and if you... I can't just catch him. He eats me. Okay, once I face the ghost, he eats me. But what can actually happen in this game is that ghosts change their form. They can be threatened. And if they are threatened, they don't eat me, but rather I eat them. And if I eat them, I gain a lot of points. So let's take a look how this application is built. We can do several things here. We can mess with the cookies, of course, and we can also mess with the local storage. In the local storage, one of the things that you can easily see here is the high score is stored locally. I come here, I change it to whatever I want, and next time it's sent to the server. The scores that I have inserted here is sent to the server and not the real one. So that's a very, very simple change that you don't really have to be to even know code how to do that. But we can do a bit more complex change here. But I have done some sort of skip here just to prevent messing with the connection that I have faced earlier. And I will show you that change in parts. What I am doing here, I'm going to JavaScript game file, which actually is responsible for how the Pac-Man and the ghosts behave. And I'm adding here a simple logic that says, the logic is here, I'm copying it. That logic says that if you face the ghost and ghost come near Pac-Man, it should automatically switch to frightened state. Okay, that is a very convenient change for Pac-Man. So what will actually happen, I will show it to you here. Okay, that doesn't work. I will open it again from here. I will show it on a recorded example. I am using a recording here because there is a complexity in the browser while reloading the cache. If I mess with the cache, there is a serious complexity how to reload it. So what I have done here in the background, I have just used proxy. I catch the payload, I change the payload, and I send it again. It's a very simple concept, but it's a bit complex to demonstrate it live. So you can see here exactly the same example of changing the code. This is a beautification just to show the format of the code. And I just paste into this file the logics that I have changed. And let's see what actually will happen in the game while this change takes place. The ghosts are chasing the Pac-Man, but while they're meeting the Pac-Man, they have been eaten and not eating me. And what happens to the score when they have been eating? The score doubles itself. Take a look. For each ghost, it doubles itself. So in this pace, we will very soon get an integer overflow, which is a very nice way to crash this game. And in general, the score, of course, will be sent to the server, and I will be the king of this Pac-Man game, which was my dream since 11 age, actually. Okay, so that's a fun way to demonstrate how business logic shall not be stored on the client side while you are considering, and that is a very important thing that has to be taken into consideration from the beginning of development. Because if you are getting to that stage and you're showing the developers, see, your business logic is vulnerable here, there is no way right now at the end to change it. So this is something that has to be taken into account in architectural and stage of architectural planning of the application. And that's why it's very important for the development department to understand that security should be taken into account from the very beginning, from the architectural stage, and not only at some stages of testing or before deployment. Because for this stuff, at the deployment stage, it's too late. You have to rewrite the whole application in order to make it secure. So that was one example that shows us the business logic. Additional thing that I would like also to show you today that is geolocation. Geolocation, it's a concept that allows, it's probably mainly important for mobile applications, but also for web applications it's used. However, the concept of revealing geolocation is very problematic. Think about it. Anyone, any place would like to know where you're placed right now, and it's really the privacy which is ruined here. So what browsers came to do, browsers are not allowing to use geolocation without specific approval from the client. And that, I would like to show you a small game, how this can be pretty easily messed with by social engineering. Who would like maybe to join me for the game, for a small game that demonstrates it? Not something complex. Would someone like to come in? Thank you very much. So this is a very simple game. You're supposed to press a button while the button is moving. Go ahead. You see, you can see it here. The button is moving. You're supposed to press it once you see it. Yeah, that's right. You can.
That's easy. What do I do with this?
You press it, really. You just click on it.
Not clicking.
It's not clicking. Oh.
Oops.
Okay, here we go. Hello. We have just opened my camera. Okay, so you, because it was not moving very fast, you have not asked it. But what actually happened here, you can see, let's maybe close the camera and take a look at the demo. Yeah, let me know.
Totally unscripted.
Let's clean it here, first of all, and go back to this game and close the camera so it won't come in our way. So what's going on here, that we are actually messing with the mouse. The mouse that you're seeing is not an actual mouse, but rather the mouse itself is over here. So you click it here, and then, in this case, it's not important. It's a bit deceiving. But while you get 3, you're actually allowing your geolocation to be shared with the site. And not just that, but if you continue playing this game and get to 5, you're not just allowing geolocation usage, but you're allowing camera. That's a very simple concept of social engineering that is revealing whatever information you wanted maybe to prevent from sharing with the application. It is now open and allowed for sharing. Thank you very much. So those are basically the things that I wanted to show you today. And here we have some time for questions, if you want. And what I came to say here is that there are a lot more of those concepts. A lot more of the HTML5 methods that can be used for some sort of some sort of messing in one way or another. But what shall be taken into account is that there is, and that developers as well as users shall acknowledge it. And this incredible efficiencies that HTML5 brings with it shouldn't be just used as it is, it should be used with caution. That's my message to you today with all those examples. Again, so can you ask again?
Bundling in the JavaScript files and code duplication. If you minify all your JavaScript files.
The JavaScript that you have seen here, let's look at it together. The one here is minified. You see, it's pacman min.js. It's minified. It's not obfuscation or something, minification. It's very clear that you can, each and every browser allows you to beautify the JavaScript. Okay, now you see it properly. You can see whatever you want, and you can go back to the minified. So messing and changing it doesn't really preventing by minification. Minification, it's more for packaging, for lightness. And it doesn't help in this case. Someone else? Here. There are, specifically for frameworks, there are a lot of frameworks used for JavaScript, and they have their own vulnerabilities, and also there are vulnerabilities that are built upon JavaScript, on your own code that you write upon frameworks, right? So using frameworks in general is not preventing you from there are some frameworks that have baked-in security features, that have packages. I don't have right now on top of my head an example, but as far as I remember, for sure Node.js brings some things inside, but that's more of a server-side JavaScript. It's not a good example for that case. There are good features, and today when building frameworks, developers take it into account. And a lot of frameworks, not just in JavaScript, also there are for Java good solutions for baked-in security. And that's something to look for. That's a good question. For HTML or for the source of your JS files too? Okay, so that's different. So there is a much less way to mess with HTML itself for the vulnerability aspect than you can mess with JavaScript. JavaScript is actual active component. And if it encrypts the JavaScript, that's great. But if it's only does that to HTML, it's not enough. Okay? So that's how far as that goes. Anyone else? No? So thank you very much for your attention here. And be careful with your JavaScript.